Hello, everyone. I hope you all are holding up all right as we close out this tough semester. You all have worked super hard, and I know I speak for the whole team when I say that we're all super proud of you. Um, I know it's a super stressful time, especially with no reading days, but we're in the home stretch. You guys all got this. So I'm just going to go through the environment diagrams from the quiz. So this was the first one. So I'll just hop right in and set up our globals frame. So we have two functions. So we have main, which is a function defined on lines 4 through 9. And then we also have a function called OM that is defined on lines 12 through 16. All right, so that's what we got in globals. And then on line 20, we call main. So our return address is 20. The return value of main is always none. So up in main on line 5, we set up a list x's. So let's draw this on the heap. So this is a list of type int, and we give it 2 elements. So we have 1, then at index 1 we have 2. All right. And then we set up another list on the heap, y's. So let's draw that. It's another list of type int, and its first element is 3, second element 4. All right, so then fun things start happening. So I'm just going to section this off. We call the OM function. So we called it on line 7, so that's where we'll return back to eventually. We see the return value of OM is none, so we can just fill that in right away. And so the first thing we want to do when we enter a new frame is set up the parameters. So let me just change the color here so we can keep track of what's going on. So first parameter is G, and that is going to be pointing to the y's list because y's was sent in as the first argument to our function call. And then we have a second parameter, EE, which will be pointing to the x's. Okay, so then on line 13, we set up a new variable in the OM frame T, which is a list that is pointing to the same place as G, which is over here. Okay, and then we say on line 14 to go to G at index 1 and make it 5. All right, and then on line 15, we say update the G pointer to be pointing to the same place as EE. So to update that, move our arrow here. And then on line 16, we say update EE to be pointing to the same place as T. Okay, and then that is all for our function. And then now we have to go back up and finish main. So we're back at line 8, and it says x's at 0, which is 1, is going to be updated to be its current value plus whatever is at y's at 0, which is 3. So this becomes 4, and the output of this is 4. So this just gives us 4. All right, so that is that one. The main concept we were getting at here was showing you how we can send 2 lists into a function call and have them update the same references on the heap that we set up in the main call. All right, let me erase this. Okay. All right, now we got the fun box example. In globals, first thing we have is this box class. So this is a class that is defined on lines 4 through 20. And then we have the main function as well, defined on lines 23 through 27. Okay, cool. And then on line 31, we call main. So we set up that RA was 31, the RV is none. All right, so the first thing we do is set up this A variable that's going to hold a box object. And so when you see the name of a class followed by parentheses like this, it should immediately make you think, oh, I better check to see if there's a constructor for this class. And there's not, there's no underscore underscore init. So there's no constructor, so we don't have to worry about making a constructor frame. So we can just go ahead directly and set up a new box object on the heap. And if we look up at the attributes here, we know every box has some X attribute that starts out as 1 as the default. Okay, so then we set up another variable, B, that is the result of calling a dot increase or inc b. Okay, so that is a method call. So we are going to go ahead and add that frame. So I'm going to leave b blank for now because we don't know what it is yet. So we're doing a call to the box inc b method. So the RA is 25. That's where we came from. And inc b, we don't know what it's returning yet. So we know when we have method calls, the first thing we want to do is set up that self parameter to the instance of the object it was called on, which in this case was this A box. Okay, so then on line 8, we set up a new box, B, which points to a box on our heap. It also starts out as 1. Okay, and then on line 9, we say self.x plus equals 1. So we're going to follow the self arrow and update x here to be 2. And then on line 10, we say b.x is equal to self.x. So we're going to update this to be 2. And then we say b.x plus equals 1 again. So this becomes 3. And then we return this same b object. Okay. So now back up in our main function, b in main is pointing here to this box object that we returned. Okay. So moving on, I didn't draw a very good sized frame here, but now we set up another box C that is the result of calling the inc C method on the B box. So I'll use a different color. So now we're calling box inc C. So the RA is 26. RV, we do not know yet. And self is going to be pointing to the instance of the box class we called it on, which in this case was this B. Okay, and it says on line 15 we want to do self.x plus equals 1. So this becomes 4, and then the return value is just this box. Okay, so then back up in main, C is going to be pointing to this box as well. All right, and then on line 27 we have one more method call. Just move something. All right, so we call, sorry, 1 sec. Now we're calling the box add method. Okay, and the self parameter in this case was our C from main, which is this box, okay? And the RA is 27. We don't know what the RV is yet. So in the add function, it says self.x, oops, sorry, and my bad, I forgot to set up the parameter, right? So we also have a parameter other that is pointing to the same place as self. So we called the method on box C, but also passed in box C as the parameter. So self and other will be pointing to the same place. So then we say self.x plus equals other.x. So this is the same thing as saying take this and add 4 to what it already is. So this becomes 8. And then the return value here becomes 8. And then we're done with everything, and this just prints out 8. All right. So let me clear this. Okay. Okay. All right, and this is a fun one. I don't know if it was fun for you guys, but it is fun for us. So in globals, we set up the node class, which is a class defined on lines 5 through 14. And then we have the main function, which is defined on lines 17 through 19. All right, so that is set up. And then on line 23, we call main. So our RA is 23. The RV is none. And then in main, we have this variable seek that we set up, but we're not sure what its value is going to be yet because it's the result of calling the node constructor. So we look in the node class, and it does indeed have this fun init method. So we're going to go ahead and add that to our stack. So node init. All right. And so first thing we want to do with any constructor is just set up the self parameter, which is some node. And every node has an X and a next. We're not sure what they are yet. The RA is 18. The RV, since this is a constructor, is this same node. And we had 2 parameters. We had low, sorry, I had this little bad spacing. So low was 3 and high was 5. And that came from what we sent in on line 18. So on line 10, we say self.x, we want to assign that to be the value of whatever high is, which is 5. And then if low is less than high, which it is in this case, we want to assign self.next to be the result of creating a new node. So we're calling the node constructor again. So I'm going to do another color. So I will set up another frame. The RA for this call to the constructor is 12. Self is going to be some new node with an X and a next. Okay. And the low parameter is the same as what was in the previous init frame. We just sent in the same value. So this is still 3, but the high is now 4. And remember, our RV is always this same object. So again, on line 10, we say self.x is equal to high. So this becomes 4. And low is less than high. So we make another call to the node constructor. And I'm sorry, I definitely should have written a little smaller. Okay. Sorry, my cat is stepping on my computer. Okay. Oh my gosh, sorry. Let me just undo that. Okay. Okay, so same thing. Set up a self that is a node with an X and a next. Okay, the RA is 12, low is 3, high is 3, and our RV is this same node. Okay, and so we do not satisfy this if statement here. So we jump down to the else on line 14. Okay, so I'm sorry, I skipped line 10. So self.x should be 3, but then we skip down to line 14 and our next is set to be none. Okay, so now that this bottom node constructor frame is done, so this was a recursive constructor, right? So now that we've bottomed out our recursion, we've hit the base case, right? This is the recursive case for our constructor, and this is the base case. So we've hit the base case, so now we can start going back up, okay? So this node frame tells us to return back to line 12 of the previous frame. And here we were constructing a node, right? And this node is not yet complete. We wanted its next to point to the node that we created recursively after the fact. So now we can set up that link. Okay, and now after that, we can return. So let me fill in the purple arrow. So this sent us back up here. Okay, and now this node's next points to the node with 4 in it, and then we return back up to main, and this sequence variable points to the head of our linked list. Okay, and I was just drawing these arrows to try to visually show what's going on, but you should not include those. All right, and so then the final step is just to make note of the output, which was just printing the X attribute associated with the head of the sequence list, which was just 5. Okay, awesome. Last one. All right. And all right. So first things first, let's set up that globals frame again. So we have the R function, which is defined on line 4 through 15. And then we have a global list, which is something we have not seen that much of, I don't think. So we can just point to the heap and set up this list of integers. So we have the first element is 1. Oops, sorry. The second element is 3. Then we had 5, 7, 9, 11, 13. Okay, so let me just make this look pretty. I don't know if pretty is the right word, but let me just make it into a table. Okay, so I think this tripped a few people up, this line 20 to 21. So what this if statement is doing, just as a reminder, is when you run your Python files as a module, which is what the python-m does, it's automatically going to evaluate this if statement to be true and then do whatever is inside of it. So as a convention, we've been calling main, but to save us space, we did not call main, and instead we made a call to the R function. And it still works the same, it's just not what we're used to seeing. So just to clear that up. So we call the R function, and the return address is 21. We don't know what the return value is. And so let's set up the parameters. So we have the x's parameter pointing to the same list. X is 5, A is 0, and Z is the length of our list, which is 7. Okay. So we say if A is less than or equal to Z, which it is, create a variable I that is equal to the floor of A plus Z over 2. Okay, so that's what this double slash means. So A plus Z is 7 and divided by 2, but drop the decimal is 3. Okay, and then x's at I is the value of our list at index I, which is 3. So x is at I is 7. And we check, is this array element that we just extracted equal to x? It's not. And then we check, is it greater than x? It is. So we're hitting a recursive case. So I'll use another color. So now we call R again. And the RA now is 11. RV we don't know. X's points to the same list. X didn't change. A is still 0, but our Z parameter, we're sending in I minus 1 to be in the place of Z. So I minus 1 would have been 2. Okay, so now we check, is this A less than Z? It is. So we set up an I to be A plus Z divided by 2, drop the remainder, so that is just 1. And so our list at index 1 is 3. And we check, is 3 equal to 5? It's not. Is 3 greater than 5? It's also not. So now we hit this recursive case. So I'll do yellow this time. We call R again. The RA is now 13. RV we don't know. We have the same list. X is still 5. But now A is going to be I plus 1 from the previous frame, which is 2. And our Z is going to just be whatever Z was from before, which is 2. So is 2 less than or equal to 2? It is. So now we set up I, which is 2, and X's is 5. And yay, now this is true. 5 is equal to 5. So we return true. Okay. And so the return address, right, was 13. 13 is inside the R function. So we look for the most recently called R frame, which is the red one. And so this true gets sent back up here. Okay, these recursive calls are linked together, right? So then same thing here, the return address for this R frame was 11. 11 is also inside of R. So we jump up there and we return true here, and then we are done. We just end up printing out true from down on line 21. And that is all there is to it. So basically what this, we didn't give it a name because that would give it away, right? This is a recursive binary search. So we are given a list and a number to be searching for. And if we find the number we're searching for, we return true. If the number we check is greater than what we're looking for, we just take the upper half, otherwise we take the lower half. Yep. And note that this works because our input list is already sorted. All right, so I hope this helped. You all will do great on the final, and I hope you have a great rest of your semester and restful winter break.